When we think about human progress, we usually picture the wheel, the printing press, or the rocket. We rarely picture a simple grid. Yet this simple arrangement of boxes is the structural foundation for modern science, finance, engineering, and economics. Today, we rely on it to make billions of decisions. But the story of how we got here started thousands of years before the first computer was ever built. To understand why it's so powerful, we have to look past the software and see it as a mechanism for organizing chaos. About 5,000 years ago in ancient Mesopotamia, agriculture flourished. Merchants traded goods, kingdoms collected taxes, and temples filled their storehouses with grain. At first, people relied on their memories to track who owned what, but as society grew, memory reached its limit. People needed a physical way to record their assets and debts. That need drove the invention of writing. The oldest written records are business data, lists of livestock, and taxes. Instead of writing numbers randomly, early accountants grouped them, names in one direction, quantities in another. This made data comparable. By giving numbers a spatial structure, early humans had unconsciously invented the first spreadsheet. Jump forward a few centuries to Europe. To keep up with expanding global commerce, merchants began tracking their finances on large ruled sheets of paper. These ledgers, literally spreadsheets, helped build governments and banks. But they were static. They couldn't calculate themselves. Imagine an accountant spending an entire week meticulously calculating a company's annual budget by hand, row by row. If the business owner announces a 15% increase in projected sales, that single new variable forces every connected number, revenue, taxes, payroll, and profit, to be erased and recalculated from scratch. For centuries, our ability to forecast the future was bottlenecked by the burden of manual arithmetic. That bottleneck finally broke in the late 1970s at Harvard Business School. A student named Dan Bricklin watched his professor erase and recalculate a Blackboard financial model over and over again, every time a class assumption changed. Bricklin asked a simple question: what if a computer could automatically update every connected number the moment one single value changed? He partnered with a programmer to create VisiCalc for the Apple II. For the first time, users could ask what-if questions and get the answers in seconds. VisiCalc gave businesses a financial justification for the personal computer. It was the first killer app, software so valuable that people bought the hardware specifically to run it. The technology escalated in 1983 with Lotus 123, which added charts and database tools. It quickly became the corporate standard. But Microsoft bet on a different future. They believed users should navigate software with a graphical interface and a mouse, rather than typing commands into a black screen. Acting on that vision, they released Microsoft Excel in 1985, allowing users to point, click, and format their data visually. Microsoft then bundled Excel into a suite called Microsoft Office. This allowed numbers, charts, and text to move seamlessly between different applications. This integration pushed competitors out of the market. Excel evolved from a simple ledger into a multi-purpose platform capable of deep scientific research and engineering analysis. Today, spreadsheets are ubiquitous. Economists use them to forecast inflation, banks use them to evaluate investments, and families use them to plan household budgets. The internet brought the next evolution: real-time collaboration. Tools like Google Sheets allowed teams across the globe to edit the same document simultaneously. Now, artificial intelligence is automating the process further. AI can clean messy data, explain formulas, and build entire models from simple text prompts. Tasks that once required specialized training are now accessible to almost anyone with a computer. 5,000 years separate the Sumerian clay tablet from the modern digital cloud, but the objective has remained constant: making numbers navigable through organization. This grid acts as a structural extension of our logic. By mapping numbers to cells, we make the connections between different variables visible and precise. Because these cells are linked, we can simulate the future. We can test how a shift in interest rates or material costs ripples through a project without any real-world risk. It is the unseen infrastructure for modern decision-making. The spreadsheet doesn't build the rocket or cure the disease, but it provides the logic we use to prove those achievements are possible.